Good evening, everyone. Thank you for joining us today for our midterm demonstration for the Mooc project. My name is Jessie, and I'm one of the team leader in this project. Our group consists of 10 people, and each team member is responsible for development tasks in at least one individual module of the system. We adopted Agile project development method in this project. Our scheduled meeting includes 3 stand-up meetings every week to timely update each other with the progress and the problems, and also a sprint meeting every 2 weeks. We have completed the first 2 sprints and is currently in the middle of the 3rd sprint, which focus on the backend API development for each functional modules. Our team adopted a full-stack JavaScript approach. We used React.js with React Router for routing and Access for API requests. The UI components are built with both MUI and InDesign, depending on the page context. As for the backend, we used Node.js with Express.js to create a RESTful API. Our database is MySQL, and we use SQLite as the ORM to manage modules, associations, migrations, and seeders. For API documentation and testing, we use Swagger to clearly define all endpoints. We also implemented JWS-based authentication, which provides secure token-based user login and access control. We used Git to support team collaboration, and the workflow follows a simple structure. A feature branch is merged into a dev branch after finishing development or making critical change to the whole project, and finally merged from dev into main. Every pull request must be reviewed by at least 1 team member, which helps catch bugs in the early stage and share knowledge across the team. We adopted ESLint, Prettier, and Husky to enforce consistent code styles and formatting before each commit, and just to write unit tests for backend API endpoints. Now I'll go through the system design and modules. Our system consists of 4 major parts: admin system, role-based access management, control management, course management, and exam management. We have separate database for development and testing purpose, which help us isolate environments and avoid accidental data conflicts. The first part is login and authentication. We use JSON Web Token to handle user login and authentication, which is a stateless authentication method. Here's how the flow works. The user submits their username and password through the login form. The backend checks the credentials, then generates and returns a JWT to the frontend if the login is successful. For any later requests, the frontend will include this token in the header so the backend can verify user's identity. Here's our login interface for the Mooc system. After logging into the system, the backend generates a JWT and stores in the cookie, which allows the frontend to send authenticated requests automatically with each API call. This slide shows how our backend handles login using the MVC pattern. System first registers the routes, then maps the URL to a controller function. After that, our controller handles the request logic, followed by the actual validation check for the user's credential. And this slide shows how we use Swagger to test and demonstrate our login API. The middle image shows the returned JWT token after login successfully. The image on the left and right side describes the case where the user tried to access a protected endpoint before and after logging in. The server returns different status codes and content respectively. The next module is menu management. In norm system, we use both roles and permissions to control what menus that the users can access. Firstly, we check whether the user is a super admin. If yes, they get direct access to all the menus. Otherwise, the backend filters the menu list based on their role and permission and returns a filtered menu tree. Then the frontend uses this tree to generate dynamic routes and only display the pages the user is allowed to see. Additionally, we also implement button-level access for each page. The table at the bottom shows how we define each menu item in the database. The core attributes include type, permission, components, path, and parent ID. So this structure allows us to manage the menu visibly and the access control in a flexible and scalable way, and also enable us to implement fully dynamic routing and hierarchical menu display based on users' access in the next stage. Now I'll walk you through the core design of a role-based access control system, focusing on the modules, APIs, and integration tests involved in managing roles, permissions, and menus. Let's start with the data modules. The role table holds basic metadata such as name and description. Meantime, we define 3 management relationships, including user role permission, and role menu. These modules work together to control user access throughout the system. And now let's move to the RESTful APIs for managing roles. Firstly, we allow authenticated users to retrieve a full list of roles and also create, read, update, or delete a single role. These APIs are fundamental for managing access in the system and are protected with appropriate else middleware. We also implemented a set of APIs that lets authenticated users to assign functionality and access, assign or replace permission and menus for a specific role. Both post and get endpoints are provided to allow admins to modify and audit access control. As for testing, we currently focus on the CRUD operations, assigning permissions and menus, error handling, and security flows, especially else validation and unauthorized access checks. The next module is user management. We designed a users table to store core data related to user registration and login, such as email, password, first name, last name, and also user status, while a separate profile table is used to store non-essential information to avoid excessive new fields in the user table. All the password fields in the user table are encrypted with Salting use bcrypt to enhance security. And as mentioned before, the users and roles tables have a management relationship, which is established through the user role table to enforce role-based access control. Besides, we've designed and implemented part of the CRUD APIs for users, and we plan to complete the rest by the end of the sprint. In our system, we consider permission management as a separate module, which provides more flexibility and scalability, especially when we need to reuse or assign permissions across different modules. As shown in the diagram, the permissions table stores each permission's name and description, along with the timestamps. We also created a role permission table to define the many-to-many relationship between the roles and permissions. On the back end, we completed the SQLized module migration and see data for permissions. We also designed the full CRUD API for managing the permissions, allowing authenticated admins to create, view, update, and delete permission records. Now I'm going to hand over to Keller, who will continue demonstrating the course management part.
Hello, it's Kayla. For the course categories, it includes the following parts. The first one is the hybrid navigation. We use tree view on the left side and category cards in the main area for quick browsing. We also do the unlimited hierarchy. It supports the multi-level listing categories for the complex course structures. In terms of the flexible management, we are easily create, edit, and soft delay categories with recovering support. We also support the search and filter functions. We do the keyword search and the visibility with status filters and the pagination for efficiency category management. We do the role-based access control, which means the teacher can view public categories only, but the admins have their full access, including the hidden categories and wall management operations. Next page. Another module is a course management. We achieve the create course, reading course, update course, and delete course. And except the normal standard CRUD, we do the search and filter functions for this module as well. We support the keyword search, status filter, and the instructor filters, and the pagination for the course list. The role, as I mentioned before, the role-based access control, it means the teacher can view specific the assigned course, and admins have the full access to create, edit, delete, and management work courses. For this part, we also do the audit trail. We can track the create, update, delete actions to have a better accountability and traceability. Next page, please. And the chapter management. For the chapter management, we do the create functions with the different titles, description, content, and the video URL, duration, and association with parent course using the order index for sequencing. And we can also get the chapter information with the specific UI API and update the chapter informations and delete the chapter. We use the cascade delete chapters with associated media files and maintain referential integrity. We also do the status management. It controls the chapter visibility with the three-stage system: draft, published, or hidden status with roles-based control. And the media integration, it supports the video URL storage and the media file associations. We track the chapter duration and manage YouTube media content. We do the audio trail as well for this chapter. And next model, please. Next page, please. Yeah, we do the course offering management. For this model, we got 3 features. We manage the offering details. We set the course for the start time, location, instructor, capacity, and more. We also use the enum-based status control. It means we use numerical enums for the course status, different numbers specific for different meanings. They track the created by and updated by, use those attributes to record the user who create or who last modified this module. Next page. And also we first directly to the Amazon S3 and show live upload progresses through the WebSocket connections and perform the basic CI/UD operations. And we also do the smooth and responsible user experience during the upload. Next page. And in terms of the question bank management, the key features are, one of them is the intuitive question editors. It is an easy-to-use interface for quickly creating and editing assessment items. We also do the topic and difficulty tagging. It means we use the categorized questions by subject matters or level of rapid retrieval, and the course linking. Each question bank can be associated with a specific course, enabling targeted assessment and the alignment. The last one is the flexible quiz systems. It means teachers can manually select questions or auto-generate quizzes based on a specific design or specific topic. Next page. For the current progress, what we already achieved is a feature design and a data model implementation. But what's going on, we are going to still doing the API development and the unit testing and the UI design. Besides, we also will continue to do the core development, and we need to complete the remaining API design and implement RBAC across all modules, and do the front-end development and rendering tree structured menu and data. And next one we are going to do is testing. For the testing, we do have the functional and non-functional testing needed to complete. The unit and integration system and the user acceptance test for the functional, and the security and usability for the non-functional testing. And next page. And we also do the Swagger for our project. Currently, we already complete the roles and the logins for the Swagger documents. And we are going to continuously build up the API for the all other different models later on. Next page. That's all for our project. Thank you for your listening.